Peace be upon you all. Hello, my beautiful students. Today we are going to make a revision on the last 4 chapters. I want you to fully concentrate and focus with me. We're going to do it in the simplest and the easiest way. But I want you to grab your notebook and your pen and let's start today's lesson. We're first going to start with electricity. So first, to talk about electricity, let's see it in this diagram. In order to say I have an electric circuit, I need all my components to be connected together. So I have a wire, I have a cell if it's only one, and if it's two, we're going to call it a battery. If we say what is a battery or what is a cell, it is a component that gives energy to the electric circuit. And we have our lamp, which is a source of light energy. Also, we have our switch to open and close the circuit. And let's say over here, we have a gap. So is the electricity going to be passing through this electric circuit? No. Why? Because this electric circuit has a gap, has a space. So in order for an electric circuit to work, we need all our components to be connected together. So let's see. I'm going to connect my wire to the other wire. Yup, it is working effectively. What if I open my switch? It will not work. So that means an open circuit. It's an open circuit because of the open switch. What if there is a gap and my switch is closed and I have something else? Instead of this gap being empty, I could use a coin. I know that coin is a metal. And metals are electric conductors. A proof for that, I'm going to attach the 2 coins to my wire. It will work effectively. So that means this is an electric conductor. So what is the meaning of electric conductor? Material allows electricity to pass through. So when I say electric conductor or electric conductivity, it is a material that allows electricity to pass through. By the way, I just said an electric circuit, it needs a source of electric power, as I showed you. If it's only one battery, we call it a cell. If it's more than one, we will call it a battery. All components connected together correctly. So they have to be all together connected. And also there is no gaps, which means no spaces open or any opened area. So if electric conductivity means a material allowing electricity to pass through, such as metals, what is the opposite of electric conductivity? We're going to go down over here. It is called electric insulator. An electric insulator is a material don't allow electricity to pass through. Okay, I want to prove on this. I'll show you right now. So let's remove this coin. I will try something else. Let's use the eraser. Using the eraser, it is not metal, so it will not conduct electricity, which means it is an electric insulator. So thank you very much for knowing this. Now, let's see what else do we have. So now you're in grade 6. So you need to know how to draw the circuit symbols. So for a cell, you draw it this way. One big, one small, line and line. If we're going to talk about a battery, if you have 2 cells, you draw it this way. Sometimes there is a question, sometimes appear and they ask you, is it better to put the 2 cells beside each other or they're further away from each other? The answer will be putting it close to each other is the better way. To draw a lamp, you draw it like a circle and an X. A wire is just like a wire, simple wire, a line. If we're going to say a closed switch, you're going to do 2 circles and a line in between. If it's an opened circuit, which is going to be because of an open switch, you're going to do it this way. This is called an open switch. If it's a motor, you're going to draw an M, circle and an M in the middle. A motor, what does it do? It spins. It makes the movement. A buzzer looks like an upside down Lego head. Like you do it like this and then the neck. This is a buzzer which makes sound. Let's say you don't know how to know this shape. You can just like draw a circle like this, or you draw a square. It doesn't matter. It appears to show you that this is a buzzer which makes sound. Now talking in electricity, we have two ways to connect this circuit. If all the components are connected together in one loop, I'm going to call this a series circuit. So if all the components are connected together in one loop, I will call it a series circuit. But there is a problem. Of course, if the switch is open, the circuit is open, it will not work. But what if my switch is closed and I have my cell and I have my lamps, but one of my lamps burnt out, doesn't work any longer. The problem here, the burnt out lamp will work as if it's a gap, it's a space, it's an open area. So unfortunately, in a series circuit, if one of the components are burnt out or removed, the whole circuit will not work. It will work as if it's open circuit. Here, parallel circuit literally comes from the word in math. It is parallel, as if you see here. Here it's parallel to this, it's parallel. This kind of a parallel circuit, we use it in our daily life, in our homes. What happens if you have a chandelier and it has a lot of lamps in it? One of them burnt out, the others will work as well. Like in your room, you have a lot of lamps. One of them burnt out, the others will work effectively. Why? Because parallel doesn't get affected by any of the burning components. Why? Let's see. So as we see here, I'm going to remove this battery and remove this cell, make it only one, enough. Let's remove this as well. Let's do a simple circuit. Okay. I'm going to put a lamp over here. Let's see. Okay, so I'm going to put a lamp over here, and I want you to fully concentrate on what I'm going to do. So it will work, and this means this is a series. Why? Because you see the arrows, it's all moving in one direction. If I want to increase the value of the light or the intensity of the light, I want to increase the brightness of the lamp, what will I do? I will increase the batteries. I will add another battery. Okay. Now, I called this series because it's all in one loop. What if I wanted a parallel? Let's do a parallel now. I will get an extra wire. I will do it like this. Put my lamp in this wire and connect it like this. So in this parallel, I see that it's moving in both circuits. Like how? What do I mean with this? Like, look over here, goes through this one and also moves through the other one. What if I opened the one in the middle? Let's break it over here and see what will happen. Did it close the whole circuit? No, the electricity will pass through the other one. You see over here? It didn't pass through this because it's open. Okay, it skipped it. It went to the other closed one. So that's why we say we use parallel in our daily life, because it's more effective. Okay, and as we said, the electric conductivity, which allows electricity to pass through, we know already our body is an electric conductor because it has nearly 70% of water. Okay, and our brain are sending electric signals as well, you know, in our nervous system and so on. That's why when sometimes you touch your friend, you get electrocuted, like you feel like an electric buzz, you know. So a proof that our body is an electric conductor. Let's see. I have a fuse over here, and as you see, I'm not touching. Like, let's start it from the beginning. I'm not touching, so technically this is called an open circuit. Let's see once I touch it from both sides, what will happen?
Go.
So why did this happen? Because once I touch, it is called an electric conductivity, which allows electricity to pass through. So that proves that my body is an electric conductor as well. So materials that are made of metal is electric conductor, and materials that are made of wood, plastic, rubber, all of those stuff which are non-metal are insulators. This is a really important information. And as well, don't forget, coppers are copper wire are copper from inside, which is a conductor, and from outside it's plastic, which is insulated. Why is it made plastic outside? To avoid you from being electrocuted once it's connected to the electricity. The last thing we could talk about is, let's go over here and go through something. Okay, let's solve this question. So the components we drew, we need to know how to draw it actually in a diagram. So looking at this first one, it has 2 cells, 1 switch, and a lamp. Let's match it to the correct electric symbol. So first of all, I will look for the 2 cells. Where are the 2 cells over here? It's either number 1 or number 3. Number 4, I mean. So this one has a motor. The only motor I can find is in letter C. So this is going to be letter C. Let's see the other one. It has a lamp. So I will write over here, it is A. Let's go to this one. The upside Lego head man, which is a buzzer. This is how the buzzer looks like, which makes a sound. We will write letter B. And this one only has a lamp and 1 cell, which is going to be one cell, 1 lamp. It will be letter D. So this is a really important question. I need you to know how to draw the symbols correctly. Also, there is a question. That's the, let's see. This question as well. Let's try drawing these electric symbols with me. Okay. So drawing the first one, you have a lamp, so let's draw the lamp. And then you have a switch. Obviously, it's on, so I will draw the switch to be closed. And then I have 2 cells. So let's draw 1 big, 1 small, 1 big, 1 small. Thank you. That's gonna be the first one. Let's go to the second one. I have a lamp. I will draw it. Then I have a buzzer. Let's draw the buzzer. Upside down head Lego man. Then I have 3 cells. Let's draw it. 1, 2, 3. Then I have a closed switch. Okay? Now going to the third image. It's a parallel. How do we draw a parallel? First, we will draw the lamp over here. It's an X. Then I will draw a switch. Then I will draw a cell. Then last thing, I will draw a buzzer. You see over here, the buzzer, how do I draw it? Obviously here I'm doing on the laptop, so you know the drawing is not going to be the best thing. But anyway, this is how you draw a parallel. And this is the lesson of electricity. Okay, so obviously there could be an information like telling you, you know why we need to use renewable energy rather than using our actual electricity. Why? To be more clean. What are the renewable resources for electricity? I will say sun, using solar panels, wind, I use wind turbines, and water, like the high dam, I use hydroelectric. Okay, those are the three resources of electricity which you can gain electricity from. This was the lesson. This is super easy. All you need to do is just study this page, and that's it. We finished the first chapter, which is electricity. Now, let's go to the next chapter. Going to the next chapter, it's Unit 7. And let's talk about two important things. It will be either light sources or light reflection. Or as we know in year 4, we talked about it. We talked about natural light resources and artificial ones. So the light sources are sun, because they emit light on their own, stars, fire, and northern lights. And honestly, I love northern lights a lot. Like, it's the best thing. I love northern lights. You can find it in Norway, you find it in Iceland. Those are not artificial. These are things called aurora. It happens in Alaska. Something in the space happens, and this is what you see like in real life. All of this is called sources of light. What about reflections? The reflections in the nature, we find it as the moon. And also there is water, mirror, anything that has a shiny surface. And if I talk about an artificial one, it is like a lamp, it's anything that man-made, like fireworks, a street light, all of this. If we talk about the three types of materials, we have transparent, translucent, and opaque. If I say transparent, it's the material that allows all light to pass through, like our glasses or the window. Translucent is a material that allows some light to pass through, some, not all of the light. And the opaque is the one that doesn't allow any light to pass through. Going to the light diagram, which is extremely important. Let's see how the light diagram works. First of all, when you draw a light diagram, you need to draw the arrow coming out of the light source. So here I have the sun. So the arrow has to be towards the object you want to see. The arrow is extremely important. Drawing lines alone is not important. It's not enough. It's as if you did nothing. Then, going from the object, it will reflect to your eye. See here? Reflects to your eye. If you're going to say, teacher, why don't I draw the arrow coming out of my eye because I am the one seeing? Nope. Reflection happens because the light reflects from the object to my eye. If you draw your eye, the arrow coming out of it, now you're like Superman. You know Superman, the laser guy, like, you know, he emits light out of his eyes. I'll show you how it looks like, because like if you're drawing an arrow out of an eye, this is how it looks like. Superman laser eye. You see this? This is basically what you draw if you said the arrow coming out of my eye. Like if you said the arrow coming out of your eye, this is it. Are you Superman? Nope. So please don't do that. Okay? So what else do I have? That's a light diagram, and this question is extremely important. Let's look at the question in the book. What do they have for us? They have a couple of pictures and saying which one is the correct image for light diagram. First one is wrong because nothing happened and didn't reflect to the eye. Second one, wrong because the arrow is coming out of your eye. Third one is wrong because it's coming out of your eye and the light went to your eye. You're going to say, oh, teacher, I see the sun. Yes, you draw an arrow from the sun to your eye if you are looking at the sun. But now, my question over here is, I want to see the flower. So the light will go on the flower and then from the flower to my eye. So Harish is going to be the correct answer. Going to something easy. If I say, let's go back to my notes. Types of reflection. We know it in easy science. I say, oh, types of reflection, that means the light bouncing off a surface. If the surface is uneven, what's the meaning of uneven? That surface is wobbly like this. So that means when the light goes through it, it doesn't go through it, honestly. It just reflects, bounces off. It will not be bouncing off evenly, you know? Disoriented, it's gonna be diffused. So this kind of diffusion, I call it diffuse reflection. What's the meaning of diffuse reflection? It's like when you are in the circus, you're looking at the mirror and you see yourself like huge, having huge arms or something like that. Let's see what I mean. So, you know, like you imagine what I'm saying. Let's say I'm going to search for a wobbly mirror circus. Wrote it wrong, it doesn't matter. I hope they just get it. Like, you know, this kind of image where you see yourself having a long neck, having a big tummy. This is called uneven surface. An uneven surface. You see this one? This is called uneven surface. Does the kid have an actually huge neck? No, he doesn't. So this is an uneven surface. We call this a diffuse reflection. But what if I say the other kind of reflection, which is gonna be even? If you know the word spectacular in English, instead of saying spectacular reflection, you're gonna say specular reflection. So let's see a reflection in nature. It will look amazing. Let's see. This kind of reflections. Look, it's breathtaking in the reflections. It looks as if the trees are up and down, like as if the trees weren't here only. It's like on both sides, you see? And let's see this one. It looks awesome. This is called a specular reflection. You see the circle? It's not like that, actually. It is only half, but the reflection made it like this. Okay? So we have the two types of reflection is going to be diffuse reflection, which is going to be uneven, and the other one is called specular reflection. Going to the mirror image. What's the mirror image? I will say it's a reversed image. How does this reverse image happen? You already see it nowadays by, I thought when I was young, the ambulance car didn't know how to spell. I was like, why didn't they go to FS1 or FS2, you know, how to spell the word actually correctly? So when I grew up, I found out that when ambulance, written reversely is because if there is a car coming and, you know, the car is in front of the ambulance and he cannot see it, so when he looks in the mirror of the car, it will be written correctly, like this one, you see? So ambulance is actually written in the opposite way, but when you look in the mirror, it will be written in the correct way. So that's why it's written in reverse. So the mirror reverses the letters. Okay, this is an important question. Sometimes comes questions in the checkpoint. So you have to be aware when you're choosing which correct answer. How? By knowing the words. The word has to be completely the reversed way. Okay, so the letters all gonna be reversed, not in the same way you are spelling. Okay, not upside down, not left to right. It's just the same way, but reversed. Okay, cool. I have something called a tool. I have a tool for looking on things that are far away. We call it a telescope. And if something is really small, we call it a microscope. But if it's a tool that is used in seeing objects that are, like I'm under the water in a submarine and I want to see above the submarine. We already know that the light travels only in a straight line. How come can I see above the water? That's like you are breaking the light. How will this happen? You will have this periscope which have a mirror over here 45 degrees and a mirror over here 45 degrees. So if I'm underwater and I put this up in the air, the light will go inside and then reflect from this mirror to this mirror and then go out, reaching my eye to see. This device is called a periscope, is used in submarines, so it can reflect the light so you can see it. And by the way, this idea also is used in medical, let's say medicine. How? Because when you have a surgery and you want to see, the doctors want to see from inside, they insert a tube to look inside. So this tube as well, you can see the image correctly. Although when from your mouth inserting to your mouth, going to your stomach, there's a lot of, a lot of curves, but it still can see effectively. That means it has tiny mirrors to reflect the image and send the image to be correctly to your eye. Now talking about the law of light reflection. So now when I look at myself in the mirror, I see myself the same size. I see if I'm behind the mirror, I'm 1 meter, I will be in the mirror 1 meter behind. How is this happening? Because there's something called law of light reflection, of reflection, which means the angle of incidence is equal to the angle of reflection. What does that mean? You don't understand, right? So let's draw it again. Let's see what does that mean. So technically, I'll just remove all of this. If I have a mirror, obviously I understand that the mirror will be an opaque material, doesn't allow light to pass through. Okay. So I have a line in the middle, which we call normal line. It's gonna be 90 degrees. This is called a normal line. When I have an incoming light ray, so let's say the incoming light ray comes here. What's the meaning of incoming? It is coming towards the mirror, incoming light ray. It will reflect with the same angle. That makes my image the same size. This is going to be called, the arrow coming out will be called reflecting light ray. So if this incoming light ray will reflect from the other side with the same angle, let's say this is angle A and angle B, that proves that the law of light reflection says the angle of, I call this one between the normal line and the incoming light ray, angle of incidence. And remember with the word accident, I used to remember it like that. It's like a coming ray and it made an accident, like hit. Incidence comes from the word incidence angle. And the reflecting light ray, the angle beside it will be between the normal line and the reflecting ray will be angle of reflection. So whenever A gets bigger, angle of incidence, angle B of reflection, angle of reflection will get bigger. This gets smaller, this gets smaller. Why? Because this is the law of reflection. That's what makes your image the same size. This is really important. What questions could come in this area? Let's say they could give you a question like, this is 20, and they tell you, give me the value of A and B. First thing you will think about is like, oh, I need A and B. How am I going to get this? So technically, we know the normal line is 90. This whole thing is 90. So you will say 90 minus 20 equals, what will it equal to? It will equal to 70 degrees. So if I know A, that means B will be the same value. So I will write 70 degrees. This is how you solve this kind of problem. This problem also could come a little bit tricky. You always think it comes from the left side, the incidence ray, the incoming light ray. No, it doesn't always come from the left side. It could come from the right side. And this is the tricky part. You have to focus with me right now, okay? Every time you draw in the book, it always comes from this side. Nope. Think of it and you have to look at the arrows. If it entered from this side, that means the angle over here will be called angle of incidence. And reflecting from the other side will be angle of reflection. So the names over here change because according to where are they going. Like the arrow coming out is the reflecting. So the angle here will be angle of reflection. Focus, you just need to know where the direction of the arrow. That's it. Okay, not a big deal. Please, when you read a question, read it till the end. Don't just read quickly. And also, if you know the information, write the whole thing. Sometimes the teacher that is marking your test doesn't know science that well. So he just looks at the answer, and if your answer is not there or like the same thing, you can miss a lot of marks, you know. So just for your own safety, don't say my hand hurts. Okay, it's just once a year. You take a test. So do your best. Okay? Oh, now you're like you're a superhero for your own story. Okay? I believe in you. So let's see. Refraction. Refraction is, I love this one. Refraction, you know? Because technically light travels in gas and liquid and solid. And when it travels, because of the particles of the gas being so far away, it's traveling its best. Speed is high speed in the liquid, in the gas, I mean. If it's going to enter the liquid, the particles of liquid, as we took in states of matter, are closer to each other. So the speed of it will slow down. So because you're high speed and you slow down, you will refract. That means you will break. Like over here, you see over here, you will entering and then suddenly you broke. Why? Because you entered a different boundary. You then entered a different state, which caused you to break. So I say the speed of light is the fastest in the gas, slower in the liquid, and the slowest in the solid because the particles are very close to each other. So refraction happens when it passes through different types of material, two different boundaries, two different states of matter. And it could cause this amazing illusion. I want to show you this illusion. I love it so much, which is the the polar bear refraction. When you look at it the first time, you're going to think that this polar bear just lost his head. It's not. He didn't lose his head. He is okay. Okay, and that's a pumpkin over there. So why did this happen? Because the light was traveling its fastest speed in the gas, then it entered the liquid, so it slowed down. This is called refraction, okay? And if you don't trust me, you can just like put your pencil in the water and you will see it refracted. Although the pencil is nothing wrong with it, you're gonna see it broken. Why does this happen? Because of light refraction. The speed of light changes from gas to liquid. Another proof in a natural phenomena I would love to show you is the lightning and the thunder. I know that this information you already took it before, that the sound travels its fastest in the, yes, solid. You know why? Let's see. Lightning and thunder. So, you know that sound, the fastest state for the sound to travel is the solid. Why? It's the opposite, completely opposite of the light. Because sound is made of vibration, and the only state of matter that has vibration is the solid. So if we are saying the light travels fastest in the gas, and the solid, and the sound travels the slowest in the gas, because it needs close particles, that means when I see the lightning and hear the thunder, to prove my phenomena or to prove my theory correctly, I need to see the light before I hear the thunder. Let's see if that's correct. Here's an actual thing. Let's see. Am I gonna hear the sound first or see the light first? So if I'm right, I'm supposed to see the light, then I hear. So till now I didn't hear anything and I saw light. Now let's see. Then I heard. So that proves that light travels faster than in gases than the sound, because sound travels the slowest. And my last information I'm going to tell you is If I have an object emitting light or giving off light, I call it a luminescent. Luminescent. So if I have a creature, living organism, making its own light, I call it bio, which is related to biology, which is a living thing. Bioluminescence, bioluminescence, bioluminescence. But if I have a creature that is making bubbles, emitting light, it's gonna be called the bubbles sunoluminescence, 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 which is an example for that is gonna be the snapping shrimp. This is how it looks like. This is a sunoluminescence. It makes this blue bubble. And what does the shrimp look like? This is the shrimp, snapping shrimp. Not this one. It is the sunoluminescence is this shrimp. What is it? Yeah, this cutie one. Sunoluminescence. While the other one, which is bioluminescence, is going to be, if you feel the word is difficult, just slow it down, you know? Just say bioluminescence, sunoluminescence, you know? Okay. So this is the firefly. It's so common in America. Instead of the mosquitoes, you know, we have this kind of fireflies. It's so nice to have it in a jar, but unfortunately it's not found in Egypt. So yeah. Anyway, I had a wonderful firefly childhood, you know. I used to have it in jars, capture it, and put it in my room and enjoy it. Yeah. So let's see, what else do we have? So technically, this is the light. Is it easy? Yes, of course. What do you need? You just need to study in actual information, like actual life, you know? Don't memorize like a computer, okay? You're not a robot. When you study, love what you're studying, okay? Like me, I love what I'm doing. So I know what I'm doing. I do experiments. I do something to show what is this and if actually it's correct or not, okay? So you try your best to not only memorize, to understand. If you understand, you will know how to solve, because in checkpoint, most of the questions are not, it doesn't depend on what you memorize. It depends on what you understand and how to think out of the box. So please come out of the box with me and study well, and let's go to the next chapter. Hello, folks. So, going to this chapter, a lot of you have nightmares because of it. So, I'm coming here to be the angel in your dark and telling you, don't worry, my fellow friend, I will take your hand and show you the path. So, let's see. First of all, we're going to talk about the easiest part. And to prove that this is easy, I will open year 4 book. Okay? So, let's see. I have the year 4 book. And I will open the lesson. Where is the lesson over here? Yes. Let's look inside of the earth. We have crust, which is the layer we are living on, which is rocks. We have mantle, which is going inside of the earth layers, will be much hotter because the temperature and pressure will increase. And then going to the outer core, which is going to be liquid. And then inner core, it will be the opposite of what you think. You think because it's more hotter and more pressure, it will be in the liquid form. No, it's not. And this is information we took in year 7, but let's tell it to you so you never forget it. Why is the inner core solid, although it's the hottest layer in all? Because of a lot of pressure. There is a lot of pressure on it, you know. So the particles are so squished and pressed, they change from the liquid form to the solid. Because, you know, if the particles are squished together, that means it will turn from liquid to solid. So that's some extra information for you to remember so you don't forget. So what about the lesson? You said it's difficult? Let's see. So our lesson for this year, we will be focusing on the word mental. Okay? And talking about mental, I love calling it molten cake. You will know now why I say molten cake, not because I'm hungry. Yeah, maybe I am, but okay, just forget about that point. So why do I call it a molten cake? Because it has the molten rocks inside, which I will be calling magma. So I find the molten rocks in the mantle, I call it magma. Then I have my fellow volcano. If the magma come out of volcano, it will be called lava. Wait a moment. Did I change anything? Nope. Here it's liquid, and here it's liquid. Nothing changed. What if I put there is a what in the air? Like once the lava comes out, there is air, there is water, and there's a lot of other stuff as well, like the temperature and so on. All of these stuff will make something called solidification. What's the meaning of the word solidification? We took this in year 4, by the way. Like you can go to year 4 and look in the book. I'm not gonna switch the books, switch the pages, I mean. Solidification is the same name as freezing, but in the state, I cannot say I am freezing lava. So the other word for changing liquid to solid, it is called solidification. So if the lava solidifies, means it will turn to a rock, because liquid rocks, this is a liquid rock. Lava is molten rocks, liquid rocks. So once it will touch the air, water, rain, snow, temperature, anything, surrounding it, it will turn to a rock. If you're good in English, we know that the word ignite related to fire. So the rocks over here are going to be called igneous rock. It will be called igneous rock. What's the meaning of igneous rock? Rocks on fire. Igneous rocks. So magma in the mantle come out of the volcano as lava once it's solidified. Solidified means what? It comes from the word solid. So we just could say solidification. What's the meaning of solidification? Turning liquid to solid. What is my liquid to solid? It's going to be a rock. The rock coming out of the volcano called igneous. Now, so as we took in the first term, we have in and x. So in means something inside and x means something outside. Examples? If I say inhalation, that means air going inside. Exhalation means air going outside. And if I say internal organs, that means organs that are inside. External, that means organs that are outside. If I say, now what I'm going to be talking about, if the lava is outside, I will call this igneous rock extrusive igneous rock. Extrusive igneous rock. Okay? But if I say it is inside of the crust, like let's say the lava didn't know how to go out, so it stayed inside. It froze, it solidified inside. I will call it intrusive igneous rock. I will call it intrusive igneous rock. So if it's outside, the lava made outside, I will call it extrusive. Lava outside on the crust, I call it extrusive. If it's inside of the crust, I call it inside, intrusive. Here, the X, it's beside of the base, right? The base of the volcano. So the example for extrusive will be base. Remember it with base. Base, basalt. Okay? This is just a thing to make you remember. And here, if it's inside the ground, right? I remember ground, so it's going to be GR, ground. Granite. It's going to be called what? Granite. Granite means inside of the ground. Inside of what? The ground. So this is the igneous rock, which is the first type of the rocks. Going to the second type. Let's go to the second type over here. Second type over here, I have, so yeah, igneous rock. We have mantle, going out to lava, solidifies, makes igneous rock. Going to the second type, you only need to say, or you need to understand or memorize the English words. So first step is going to be weathering. I didn't write it over here, so let's write it. Weathering means, you know the weather? Like the rain, wind, all of this temperature and all of that. So all of those processes will help in breaking the rocks. So the wind and all that, which we call it weathering. When the rocks are broken, we call it sediments. Broken rocks are called sediments. If I'm going to transport it from one place to another by water, by air, by wind, you know, because the wind makes the things travel from one place to another. You're gonna say how? Like, you remember, it was like a sandstorm a couple of days ago. This sandstorm was carrying soil in it, right? And sand, which is sand. So the erosion means the movement from one place to another. Movement of what? The sediments. Sediment is what? Broken rocks. If you're thinking of teacher, why are they saying sediment? Why didn't they just write breaking rocks, broken rocks? Because this is science. We have to use scientific words, okay? Because it's easier to say erosion, for example, than saying the movement of the broken rocks from one place to another by wind, water, and ice, and so on. Instead of saying all of this, you just say erosion. The process of you squishing rocks above each other for millions of years comes from the word sediment. We will call it sedimentation. In this process, we don't use heat, we don't use any fire. So this is the only place where you can find fossil. But first, before we say we find fossil, we make a rock called sedimentary rock, which is like the sandstone or limestone. Sedimentary rock. What's sedimentary rock? It's made of sediment. Why do I find fossil, or what is fossil? So fossils are like the plants or the animals that died millions of years ago, and it got squished between the layers, you know, when the layers are being packed above each other. So it got squished in between, and that's the only rock you can find fossils in. You can find fossils in the igneous because it's on fire, you know? It's impossible. Like, if you have something on fire, you would never find anything in it. So when I was young, I thought they colored the rocks, but it turned out because of the packing of the rocks among the years, it had those different colors. That means could take from, this is 1,000 year, above it 1,000, above it 1,000. And there is an important question. When they ask you about the oldest layer in sedimentary rocks, it's this one. This is the oldest layer. Going to the top, this is the youngest layer. If you're going to say, no, this one is the oldest, brother, do they build a building or a tower from the 10th floor before the first one? No, that doesn't happen. So just like be realistic. So any colorful layers are that, like sediment, those are sedimentary. Those are not AI. This is actual thing. What about the fossils? Let's see the fossils. Here, if you just have the shape of it, not the actual thing, you say trace. But if you found like the actual bones, like the creature itself, this is gonna be called cast, and we can find it only in the sedimentary rocks. Going to the last slide, I call him the thief. Why? Because he took the igneous and sedimentary rocks, then he put with heat and temperature, heat and pressure, mixed it together, but not with the temperature of magma, because, you know, if it reaches the temperature of magma, it will turn to igneous. So it's just like a little bit of heat and temperature, and this process is called metamorphism. What's a metamorphism? It's when the igneous and sedimentary are being mixed up with a little bit of heat and pressure. Not a little bit, like, you know, heat and pressure. And they make something called metamorphic rocks, which is called marble. What's a marble? You find it in your home, in your kitchen table, everywhere. And it's a mix of both igneous and sedimentary. I will show you a marble and show you that is 100%. You can see it with your own eye. That's sedimentary. It's a metamorphic rock. So let's see over here, marble. So here, let's see, marble, rock, home. The ones in homes are the ones that are better, because you can see actually the lines. I can't find the one that I'm looking for, but wait a second. Marble. You can see it like this one. But this one was like, yeah, this one, yeah, this one. You see here, the lines? Like the yellowish one looks like the sedimentary because there was actually some sand, you know? And the dark lines are the igneous, but not those one. Of course, this one's is like artificial, you know? I'm talking about the ones you can find at home that are the actual ones. So with the ones that have mixture like this, we call it the marble, and it's metamorphic. It's a thief guy. Why? Because he stole both igneous and sedimentary. So this is a rock cycle. It's easy to know. You just say it's the same information, but like let's mix it up together. If you don't think about it as if it's hard. Like I say over here, I have metamorphic rock. So a metamorphic rock, if I melted it, so I melted it until it was magma, for example, it will turn to igneous rock because I said magma is igneous rock. What if I broke the igneous rock, like I did sediments by weathering, and then I made erosion from one place to another? It will turn the rock into sediments. Okay? If I took the sedimentary rocks and broke it, it will be sediments. If I took the metamorphic rock and I broke it, it will be sediments. What's the meaning of sediments? It is the broken rock. So weathering and erosion on any kind of rock, it will make sediments. You want to turn the sediments back to a sedimentary rock? You do something called sedimentation. What's the meaning of sedimentation? You are packing the rocks on each other. Okay? Now, if I put heat and temperature on igneous and on sedimentary, it will make me my thief guy, which took igneous and sedimentary and made me the metamorphic rock. This is everything about the rocks. So if you thought the rocks were difficult, no, just think about it like the story I told you and everything will be fine, my friend. Don't worry. Now let's go to the last part in this lesson. So you understood the rocks. You don't understand it? Okay, you can go back to the video, slow it down here, and understand. Do not memorize, you need to understand. So the fossils, we said we can find it only in the sedimentary rocks. And we said it either could be a cast, which is found in the sediments hardened in the form of rock, or a trace fossil where you don't find the actual body. You just find a trace, or you could find an egg or a soil waste, which means this creature was here one day. So when you find a fossil, you need two scientists. One scientist to study the rocks and understand what kind of land was this. Was it underwater? Was it in an ocean, in a sea, in a desert, in a forest? So who studies the rock? A scientist called geologist. So the geologist study the types of rock. So technically when you find the fossil, it's in a rock, so the geologists study it. The bones, you need to study it. And you need to know, is this an extinct animal or endangered animal? Or is it a human? What kind of creature is this? So who's studying the fossils and understanding everything about its nature? The paleontologist. The paleontologist. Like, there is a genus record having all the records, everything being recorded and all of the stuff. So the same thing for the fossil. There is a fossil record having each group being discovered on Earth by human and writing the exact time. So whenever you find something, you are going to look in the fossil record and identify when was it, what was its age. Okay? So fossil record is being discovered, finding things being discovered, okay, already. And if you didn't find it in the fossil record, that means you made an discovery, and you can put your name. Yes, you can put your name. Another question, am I gonna get famous? Yes, you will get famous. Am I gonna get money? It depends on what kind of fossil you found, okay, in which country as well. So this is all the questions related to the fossil. Where can I find them? You go search in the middle of the desert, middle of nowhere, literally. But it's gonna take a lot of effort, you know. But nothing is impossible. If you love this kind of stuff, go for it. But not now, after you finish your quiz, because you know all your passion and all your imaginary stuff wants to do it nowadays. Don't do it now. Do it in your summer vacation. So, the index fossil. What's an index fossil? It's a fossil when you find it. It helps you to indicate the age or what this is exactly. Like, for example, Wadi al-Hitan. Wadi al-Hitan, the index fossil for it was like you finding shells, finding skeletons of fish surrounding the area. So you know that this area once upon a time was a sea. There was water here. So the index fossil helps you to identify everything. This is just the information for fossils. And let's see. What else do we have? Before we go to the soil, we know that sedimentary, we said the weathering breaks the rocks, turn it to smaller rocks, which we call sediments. This sediments is called soil if it's super small. So the soil, before we go through the soil and knowing everything about it, I need you to know this English word. This is the last English word you're going to take new, and then everything is fine. Drainage. D-rain-H. Drainage. What's the meaning of drainage? Drainage, allowing the soil to pass the water through. So the word drainage is important because you're going to be differentiating between the types of soil. How many types of soil do we have? We have 4. One of them is a thief as well. As I told you in the rocks, also in the soil we have a thief. Let's see. So the upper layer of the soil, if we're talking about the layers before we talk about types of soil, we have the upper layer, which is the topsoil. It's thick and it has humus. You want to remember it? Just remember it with hummus. It has hummus in it. And then you have the layer in the middle, we call it subsoil. So the upper layer is called topsoil, the one in the middle is called subsoil, and the one in the bottom with the lumps of rock, which makes the ground firm, so you can stand and you don't sink. It's called bedrock. Bedrock. What about humus? What's humus? You know when the animals are dead and the plants, so they start to rot? Though this is the humus, and it's organic material. Organic, that means there's creatures in it. And the bacteria feed on the remains, which we call it in science decomposers, feeding on the remains. And then we have the inorganic soil, which is sand, silt, and clay. You already know, and you go to the beach, once you leave the water on the sand, it absorbs it quickly. That means the drainage in the sand is quickly. And the particles of the sand can be seen, so it's a large particle being seen with the eye. And because they're large, they're gritty, you feel like, feeling rough. Silt is in between. It's like the liquid, like solid, liquid, and gas. Like gas is like the sand because it has large particles and drainage water quickly. Silt is in between. The particle size are medium and the drainage is medium. The clay. So if you're in a country house, like I'm nowadays, so in the place I am, this house is in the countryside of my family. When I went there and it was raining, the whole street was super muddy, and the water didn't disappear in a day or two. It was there. Why? Because the ground wasn't made of sand or silt, it was made of clay. And clay, the water drainage in it is slowly. Okay, so it feels sticky. These are the 4 types of soil. And the question here, which type of those 4 is the best for gardening? So as we know in the rocks, there is one that stole igneous and sedimentary and called himself metamorphic. In the soil, we have as well another thief, loam. What did loam do? He stole sand, silt, clay, and a large amount of humus. What did he do? He did a mixture, and he called himself loam. And this one is the best for gardening. You want a farm, you just use the loam. It has the characteristics of all four types. You know, when in don't tell me you don't know Thanos, okay? If you don't know Thanos, don't watch my videos, fellow. You have to know Thanos. Anyway, in the end game, you know, when he was stealing the rocks of the life and he took all of those in his gloves. So he took all the superpowers of everything in the life, you know? And then he did the snap, you know, where Iron Man died. This is the scene I was crying in. But okay, doesn't matter. This is not our subject. So this is the loam. He took the life out of every kind of those, and he took their superpowers, like making the ability for the roots grow easily, absorbing water and minerals, draining the water quickly, or better way, and also holding water, because it took, like, you know, superpowers from all. This is the types of soil, and this is the whole lesson for the rocks and soil. So it's not hard after all. And I'm gonna show you Thanos before I go to the last chapter. This is Thanos, my fellow friends, if you don't know him. This is Thanos. He stole all the crystals, jewels for life, and he took all the superpower. I feel Loam is like him because he took all the superpowers for all the soil. Thank you very much. So now let's go to the last lesson. And actually, I didn't do anything except doing a presentation for the moon phases, which you took it in year 3. And this is year 4. Like these, I didn't do anything new. So the last chapter now is going to be related to year 4. So let's start. Once upon a time, I had my beautiful planet I am living on, Earth. This picture, I love it so much. I forgot to show you in the previous lesson, so I'm going to show you now, you know? So here's the crust, the upper layer, mantle, magma inside, then you have the outer and the inner core. And going downwards, the temperature will increase. And as we said, the inner core will be solid. Okay, cool. So now our Earth, after we finished what's inside of it, we will go outside of it. Let's go outside. Opening book for year 4. Having the planets, which is the solar system. What is the solar system? It is our 8 planets, the stars, meteoroids, comets, sun. So, in the solar system, I have the biggest star, which is the sun. Does it move? Nope, it's in the center. What's happening around the sun? The planets are orbiting. If you said orbit, correct. Spin, correct. Rotate, correct. In a shape, is it circular? Nope. It's an elliptical path. Elliptical path. Why did you call it ellipse or elliptical path? Because it's an oval shape. You're gonna tell me, oh, so why didn't you say oval? This is science, brother. Are you new to this game? You know, science have its own scientific words. So here, we're gonna be calling elliptical path. Okay, cool. So all planets revolve around the sun in an elliptical path. Let's talk about the Earth specifically. Earth orbits the sun in an elliptical path. Is it clockwise or anti-clockwise? It's anti-clockwise. Cool. So Earth rotates the sun in an anti-clockwise. For the Earth to rotate the sun, how long does it take? It takes 365 days and a quarter, which is 1 year, which is 4 seasons. What about the moon? The moon orbits the Earth Yes, there is a path, elliptical path around the Earth has a moon. The moon orbits the Earth. The rotation of it anti-clockwise. How long does it take for the moon to orbit the Earth? It takes 1 month. You want to prove? Okay. When Ramadan comes, they say, هل هلالك يا رمضان. So why did they say that? Because to know that Ramadan start, you have to see the crescent in the sky. Okay. When Eid comes, they don't say tomorrow's Eid. They have to say, we will wait until Mr. Someone will look with his magnificent telescope to tell us if tomorrow's Eid or we're still gonna be fasting Ramadan. So what are they seeing with the telescope again? They're seeing the moon. So why are they looking at the moon? They do not know the shape? Nope, they know it. But to make sure that the month ended, we know by the moon ending the month. So the starting of the month with the crescent and we end it, we know when did the month start and when did the month end from the rotation of the moon around the Earth. You will never forget it, right? Okay, so moon orbiting the Earth takes 1 month. Okay, sometimes it's written 29.5. Okay. And we have an imaginary line. I call it Sikh shawarma. You know why I call it Sikh shawarma? Because shawarma, is in front of the furn and, goes on all the sides, spin, on all the sides, so it makes it crispy and متحمرة. So this Sikh shawarma, I call it in English, axis. What does it help in? It helps the Earth to rotate around itself. Takes 1 day, which is 24 hours, which is day and night. And the easy question, if the Earth is facing sun, it is day. And the other part will be night because it's not facing the sun. Is axis an actual Sikh shawarma or an actual line? No, of course it's not. It's just an imaginary line, and also the orbits are not actually there. They're just imaginary lines to make us understand more easily. What else do we have in this lesson? We have the first 4 planets are called inner planets, which is rocky planets. You want to remember them easily? I remember them since I was a kid by the word mivam. And then here, J sun. What is that? This is a word I made up to remember the arrangement of the planets. Mivam, Mercury, Venus, Earth, and Mars. Inner planets, which is rocky. Then we have the gas giant planets. Gas. They are J sun, Jupiter, Saturn, Uranus, and Neptune. Easy to remember? Yep, you're just going to say Mivam, J sun. Then we have a belt in the middle. We call it asteroid belt. What's an asteroid belt? We took it in year 4. It's a belt made to separate between the inner and the outer, Mars and Jupiter. It's made of asteroids to separate between Mars and Jupiter. So my friend, don't think a lot. Just understand. It will be easy for you. Yeah, people, don't tell me there are 9 planets, okay? We said Pluto from a long time is not considered. I hear you. I know what you're saying. You're saying why it's not a planet. Okay, even if you didn't say why, there's another person. Don't say that you didn't say, okay? Don't make it a big deal, okay? Pluto is not a planet because it doesn't have an actual orbit. So it's considered as a big rock and they kicked it out from the solar system. End of case. So we have Mivam, Mercury, Venus, Earth, Mars, inner planets, rocky planets. And we have the gas giant planets, which is J sun, Jupiter, Saturn, Uranus, Neptune. And in the between Jupiter and Mars is asteroid belt. Let's see, I made something as a revision. So there's a word here, it's not written in the book, but yeah, for your information. Like rotation is the word you use to say that the Earth spins around itself. But what if the Earth is spinning around the sun? We call it revolution. Yeah, it's not in the book. But don't tell me it's not in the book, Just understand it, know it for yourself. Maybe it comes, so you understand. اوكي؟ متقولش ورايا حفظ كتير. ماشي؟ يعني كلمة واحدة مش هتأثر معاك. كلمة زيادة بس عشان تبقى مثقف كده و scientific person. Okay? So, revolution is Earth orbiting around the sun, which is 365 days and ربع. 4 seasons, which is 12 months. And the rotation is for the Earth spinning around itself 24 hours, which is 1 day, which makes day and night. What's similar between both? They are anti-clockwise and they move in an elliptical shape, this oval shape. The moon orbits the Earth in 1 month. The moon orbits the Earth in a year if it orbits the Earth in a month. That means in a year has 12 months. That means it orbits the Earth in a year 12 times. Okay? And yeah, the axis over here is not right angle. It's like tilted with a 23.5. Thank you for praising my drawing. I did this by myself. You love my drawing? You don't? Okay. Thank you. Let's go to the last part. Last part is easy, my friend. But before we go to the last part and the thingies, let's look in the book. Let's take a peek. Let's see if we forgot anything. Just a second. Okay. In the book. So yeah, they said the giants and nothing else. Okay, let's look at this image as well. This image, which one's the correct one? It's gonna be letter C. Why? Because the sun is in the center. Yes, it's in the center here and in center here. But the first one is wrong. Okay, the moon orbits the sun. I mean, the Earth orbits the sun. Yeah, it orbits here, it orbits here. Good. The Earth has an orbit for a moon around it. Nope, it doesn't have an orbit around the sun, and it doesn't run after the Earth. Why did B and D, why are they wrong? Because each planet has its own moons. Saturn has 82, and last day we checked that Jupiter had 97 moons orbiting it. And by the way, we took in year 5 that the natural satellite for the Earth is the moon. Okay, cool. So, going to the last part. Are you ready? I don't hear you. Yeah, that's SpongeBob. But let's go back to, sorry. So, we have over here our phases of the moon. You're gonna say it's tough? Brother, you took it in year 3, and most of you made the Oreo project. You don't remember? I'll show you the project. But honestly, for me, if I had the Oreo project, I was gonna eat the Oreos and say the moon just disappeared. Our project, moon phases. Here, you see? This is the phases. Most of you made this easy project in school, okay? So that was in year 3. So let's go through it again in this colorful way. We said for the moon to orbit the Earth, it will need 29.5 days, which is a month. It's anti-clockwise. Cool. It's an elliptical shape. Great. So, thinking of when you start a new game, do you have any skin? Do you have any powers? Do you have anything? Nope, you don't have anything. So, when you start a moon, it's completely dark. It's a new moon. Okay, cool. After that, you don't need to know all this information. That's just extra. You just need to know new moon is completely dark. After that, it will be on the right. The first lightning part, the luminant part, will be called waxing. When you are on the right, it's going to be called waxing. If it's the small portion, this one small part, I be calling it waxing crescent. Then it will be half of it. But we will not call it half. We will call it quarter. Why it's half? Can't you see, teacher? It's half. I know, brother, but this is a 2D picture. We are talking about the moon. It's 3D. So technically, when I say the first quarter, this is the part being on light. Okay, the other part is not. So this is why I call it first quarter. Okay, because this is a 2D picture. You don't see that from the behind. So going in, I start a new moon, a little bit light, we call it waxing, crescent. Half of it, we call it first quarter. The big part, big boss. You're gonna say, where's big boss? It's called gibbous, teacher. I know, first of all, we call it waxing because it's from the right side, okay? Big boss, I remember it with this. B-I-G, boss. I know it's gibbous, I know, but I just like B-I-G the opposite way to remember it. So when it's big, big boss, but it's big, gibbous. So this is a waxing gibbous. Honestly, you can just guess it by yourself. This part is gonna be on light, so it's just gonna be, this is gonna be meaning, what am I saying? Okay, anyway, whatever I said, this is gonna be called full moon. Why? Because the whole thing is on light. So when the whole thing is on light, it will start to disappear again. It will disappear from where? I started to light from the right. So that means it will disappear from the right. Is it gonna be the same word as waxing? No. It will be called waning, but the same word, gibbous, because it's big. And then the last quarter. And then a smaller portion, which is gonna be crescent, but instead of saying waxing, we're gonna say waning because it's closing now. And then it will go back to the new moon. And this is the movement of the phases of the moon. The phases of the moon, this is how it is. So just understand it in an easy way. And remember, we start to light from اليمين because we are أهل اليمين. We start from the light from the يمين, okay, from the right side. And so I'm going to show you two pictures I took. I want you to praise me taking pictures, okay, my friends. I'll show you now. Where's the pictures? Okay. Look over here. I took this. And over here, it is a gibbous, 100%. It is gibbous, big boss. But I don't know if it's waning or waxing. So it started to light from here and it's trying to finish, but didn't finish yet. So that's gonna be called waxing because it's trying to finish. It didn't finish yet. But let's see the other image I took. The other image is, see this one? I took it as well. I'm a professional photographer. Thank you, thank you. Anyway, it's starting to disappear from above. So this is gibbous as well, but it's disappearing. So it's going to be the opposite, which is going to be waning gibbous. Do you understand now how to know if it's waning or waxing? Easy, my friend. So this is the end of the whole semester. Like this is everything, you know? So we started with electricity, finished up with the phases of the moon. We took the 4 units, and I already made on my YouTube channel, I made the first unit. I know there is a couple of units in the middle. I'm gonna check them with you. Let's look at it. If you want them, just like write down in the comments. I don't know if you reach this part or not, but if you need them and you feel like you need a revision on them, just send me and I could make a brief summary as I did now. And like what I did for you on YouTube is this one. It's already there. And today I made you those 4 units. So you just have those missing: forces, unit 4, and all of this. So you can find the reversible and irreversible and forces. You can find them in unit 4 and year 4 and year 5. It's there. But if you need an extra information or from the book, just let me know in the comments. And I hear you, the one that's telling me, oh, you made a long video on YouTube, teacher. This is a lot for me. Bro, don't take it all in one day. Just, Trim it. Don't take it all at once. Take a part and then study it and then come back, okay? And then leave a good comment for me, please, because I love you guys and this is all for you. I hope you get the best marks ever. And if you need anything, my number is below. You can call me, not call me. No, don't call me. Sorry, I'll take this back. Text me on WhatsApp, and whenever I'm free, I'll text you back and tell you whatever you need. Hope you have a nice day, and hope you be your own superheroes for your own story. Goodbye.